let's start, I would say. Or door? Can everyone understand me, or is this too loud or too okie dokie? I hope my appearance today is not too distracting. I did a huge mistake last Friday. I went outside, never a good idea, and got a sunburn now. Even though ChatGPT tried to warn me and told me, think of your sunscreen protection, but I was, nah, I'm Asian, I don't need something like that, and no, I can peel off my skin off my face. But we will manage. But ChatGPT is basically our topic for today. We talk about AI agents and AI agent systems, especially our own agent system called a Flock. It sounds like an advertisement talk. It probably is one, but I will promise you, you will get something out of it. And hopefully your mind will be blown like my mind whenever I show people a Flock. First, we will talk about why agents, just a quick recapitulation, because you guys probably heard already hundreds of times what agents are and why they are the next big thing. Then I will talk about tales from using agents in real projects and the pain that comes with it and why we decided to do Flock because of those pain points. And at the end, we will look at some demos, and the appendix is basically for the booth presentation if some of you decide to visit me later at the booth. So who am I and why am I standing here? I'm André. I'm started as a cloud solution architect with Pydantic 10 years ago or 11 years ago. Now my card says AI solution architect because I'm basically the AI nerd of the company. I already did AI before it was cool. Basically 20 years ago, I had my first big AI project by doing a neural network that could do music and could do jam sessions with me. That was basically my first introduction to AI. And since then, I basically reading everything that's coming out. So literatures, paper, everything. And last but not least, I'm the guy who came up with Flock because of the stupid stuff you have to battle with when working with agents. Short stuff about our company, White Duck. You probably know us already because we organized this event here. And our company basically consists of 3 pillars: the cloud native development, platform engineering, and developer productivity. AI, of course, plays part in all of those 3 pillars. And if you need help with any of these stuffs, feel free to reach out. We are glad to be of help. So, agents. So, in the beginning, there was the chat, and people saw, the chat is amazing. And GPT 3.5, everybody was, generate me some jokes and generate me some stories. And it was nice, but it wasn't really usable for real work use cases until 2021. Someone came up with a RAG, retrieval augmented generation, meaning you put information during the query process for the LLM, and the LLM will work this into its answer so it looks like it actually knows it, but it's basically on-the-fly food information addition. And over time, people thought I could use LLMs and control agents with it. And probably all heard 2025 is going to be the year of the agent. I'm thinking 2026 or 2027 is more realistic because 2025 is still the year of the experimentation. with agents, but not real projects is kind of fuzzy. And where does this go? Basically, in the future, we will have agent swarms, like most big agents today, like Cursor or the new ChatGPT agent, are basically agent swarms. Thank you. There are basically agent swarms consisting of multiple smaller agents that get orchestrated by the host applications. And that's where our journey is taking us. That's something we will all have to work with in the future. Satya Nadella said once, SaaS is dead. And in the future, instead of service-oriented architecture, we all do agent-oriented architecture, so you have basically only agents that orchestrate themselves in agent swarms and will provide the user with whatever the user wants. And what exactly are agents? Agents basically a piece of software which is acting autonomously. It doesn't have to be AI. For example, your spam filter in Google Mail is also an agent because it does stuff without you telling him to do stuff. But with LLMs, the idea behind it is to make those agents more powerful and more advanced, being able to do more stuff that normal agents, hard-coded flows can't do. And usually, agents react to their environment. They exist until something happens. Then they collect the information they need, come up with an action, do the action, evaluate the action, and repeat until nothing is to do anymore, and then they are done. Agents are obviously not a new concept. I think the first mention of an agent in computer science in the literature was 1960s, around this time. And like I said, the idea is with LLMs to give agents basically a brain for more advanced use cases. And how could such a use case look? With LLMs, basically, you have an input, the input get passed, and with this passing, information gets gathered, and based on the prompt it has, it will do stuff by using native tools or other agents or MCP, which is basically a collection of tools. And based on this, it will choose an action, update its states, will generate an output, and sometimes, not always, there's a feedback loop, so the agent can iterate on the process until it's finished. So all of this sounds pretty nice in theory, but who of you already worked with agents in a project, in a real project, not just POC, but, and you probably have the same pain points as me or stumbled across the same. For example, in all our projects we had so far with agents, the single worst problem we experience is the prompt. Every agent has kind of system prompt which explains to the agent what he needs to do. And in my opinion, perhaps I am too old-fashioned, but natural language has no place in software engineering. And it blows my mind that people take it for granted. So yeah, it's a necessary evil to interact with LLMs, but it's pretty big evil if you ask me. Because when I started my journey as a cloud solution architect, I got told that my job is to provide the best possible software to the client I could. But if I look at such a prompt that's 30 lines, and it's just a half of this real prompt of this agent framework. That's not our agent framework, by the way. How do you know that this is the best prompt it possibly can be? How can I go to my client and say, yeah, that's the best version of it? Because how do you unit test a prompt? And the joke is you don't. You can probably say, well, 90% of the use cases, it will do its job, but then you stumble across the next problem. How do you improve such a prompt? Do you go line 7 and replace 3 words, and then you test again, and it's basically just guessing and having luck to actually find a better prompt. There is no system behind it, and it burned plenty of resources in projects so far, because at the end, everyone is basically just busy optimizing prompt without knowing if it's fruitful or if there's some pot of gold at the end of the rainbow, and where everyone is, yeah, it happened, it works. And of course, smaller pain points with the bigger agent frameworks is one bad LLM response can kill your complete agent system. Testing, I already said. Structured output, it's okay now, but 2 years ago, this was very painful to get structured output out of an LLM instead of natural language. And other pain points are orchestration limits. For example, LangGraph. In LangGraph, your agent system needs to form a DAG. A DAG is a directed acyclic graph, meaning it needs a start point, an end point, and you are not allowed to do loops, no self-referencing and stuff. And when I read this, I'm thinking, yeah, why? Why can't I do loops? Why do I have a fixed endpoint? Why can't my agent run forever? And stuff like this. Production gap, if I do AutoGain Jupyter Notebook, this one probably scale to enterprise. And I'm basically contained in my Jupyter Notebook until I do real hard work to get it where I want it to be. And of course, with open source software, support is basically non-existing. If I have a problem with LangChain, who am I going to call? Mr. LangChain, I have a problem. There is no Mr. LangChain, and worst case, I have to interact with people in the GitHub issue boards, and bro, who wants that? So basically, I would try to collect some pain points we identified with other agent frameworks. It can be that this is a little bit out of date. So if some guy of Microsoft is here and says, AutoGain can do this and this, sorry, then, but it won't. It won't kill my point, so to speak. And our goal was to create an agent framework where every line is basically a green checkbox. And so Flock is born. So what does Flock differently? I like to call a Flock is a no-prompt agent, and then people are like, what is he talking about? How can you have agents without prompts? We will see in a short time, but its core philosophy is being declarative, meaning imagine you sit at your favorite Italian restaurant and you order a pizza. And a declarative would be you say, I want my pizza Hawaii. Then the guy goes and come back with your pizza Hawaii, and implicit would be to explain your waitress or your waiter the 30 steps the chef needs to do to get your pizza. And That's what Flock basically also does. You only define what goes into the agent and what you want out, and everything else is basically the AI decides the rest. And why not use the AI for such things if when I have already the AI in my hands? So we basically solve these issues with having blocks of natural language prompts by defining stuff like this declarative, which provides clean contracts I can test. They are regressionable, and of course, 2 lines of declarative definition is easier to understand than 50 lines of code prompt. Also, we have integrated temporal I/O into our agent framework. If some of you don't know temporal I/O, it's basically Drupal functions for Microsoft in good. It's a workflow engine which enables the systems you implement temporal I/O in to have automatic read trails, state persistence, workflow assumptions, and all the other stuff. Basically, our agents cannot die, because if they die, they can be booted up again exactly at the point where they crashed. And all the fancy stuff temporal I/O brings out of the box, like monitoring, debugging, timeout handling, all this stuff gets basically done too. And so far, we are the only agent framework who supports temporal I/O, basically. And this alone is a huge boon for working with agents if you know that your agents basically are unkillable. And of course, everything else you would expect from an agent framework, like deep modularity, like you can in Flock replace everything with everything, meaning you don't even have to call a LLM as a brain for the agent. You can even have agents that are static, like they execute your hard-coded workflow instead of calling a LLM, and you replace only the evaluation part of the agent, and everything else is basically also replaceable. It has MCP support. It allows complex chaining, like however complex you may connect the agents, it is possible. It's thread safe, which funnily most agent frameworks aren't. And multitask viable, I can run 20 agents in parallel and everything still works. And Flock offers developer tools. For example, I can give QA my Flock agents and they get UI where they can enter feedback, for example. So I, as a dev, can see the feedback, and which makes developing agents quite easier if there's something like feedback, and later, so that's a planned feature, we want the agents to learn on their own on those feedbacks, so they optimize themselves based on feedback devs or QA give the agent framework. So a short summary of everything we saw until now. Declarative contracts, built-in resilience, actually testable, optimal quality. This is like in quotes, because agents also possess multiple algorithms to optimize themselves based on latest research. There are currently 3 or 5 algorithms, self-play and self-learning algorithms that would help agents to optimize their own processes. Dynamic workflows with conditional routing and intelligent decision making, meaning your agent system doesn't have to be fixed. You can have, for example, AI-based orchestrator who decides which agents get called next. And basically, you can deploy Flock without any config or any other time-consuming stuff by just calling it with a parameter, and oops, you have a REST API with Flock where you can call every agent per REST. And if you want to take a look, it's a Python package called flock-core. But before you all go check it out, we are looking at some demos the last 10 minutes, so you get an idea what I'm talking about when I say promptless agents. Is this big enough or good? So I hope everyone is a Python master, so he can follow. Now it's not very complex, and it's relatively boilerplate free. So hopefully it make it relatively easy to understand. Line 4, I basically instance my Flock and give it a model. Azure GPT 4.1 should be my LLM of choice. In line 7, I create the agent. It has a name called idea generator. It has an input property, an output property. And you can see I only write input is a topic, and output should be a catchy title and some key points for this topic. Then I add the agent to my Flock, give the agent data to start with. For example, I chose the future of AI agents as topic, and then I run it, and hopefully no, this looks good. And as you can see, he got the topic and produced a catchy title and key points without me needing to write a huge book about how the key points should look and what a topic is and what I want from it. And if I want, for example, to add something like a list of So I added a property list of fitting emojis, and also here he knows what to do without me needing to explain in detail what I need to do. And as you can see, it makes the whole working with agents a bit more elegant because I don't have to write my natural language prompt. I only need to write a specification, a list of what I want to get in and what to get out. So most of the time people are asking, but what if I want to define something like something has to be a number or something else needs to be a list? No problem. You can go and define the data type of each property. For example, hello. Thank you. For example, this is a movie generation agent. It gets a topic for a movie, and it should generate a fun title, which should be a string, plus a description. It should be a funny string. It should provide a runtime as an integer, a synopsis, and characters, which is a list of dictionary. Just to showcase that it can be complex as you want, the data type. And it did, as I said, runtime is an integer and characters is a real list. I can access like you would a normal list in Python. The output is already a real Python object. I don't have to do any parsing or any post-processing. It's already in the format I defined. And of course, people are then saying, but what if I have already my business objects, huge data objects, huge classes or definitions of how my data should look like? Also no issue. I can define my DTO with Pydantic. If you don't know Pydantic, it's like a library for defining models and working with models. And this is, for example, how I would define a model in Pydantic. I have my class and write down the properties I need. And we have here some Dungeons and Dragons character generator. And all I have to do after I defined my class is to decorate it with a flock type. So flock knows this is a class I need to work with, and in the agent you can basically use this class like you would use any other data type. And if I And as you can see, he generated 2 characters for me in the same exact data format I have defined. And then people are saying, but what if I have complex processes? What about these? It probably is going to be our last example anyway, then time is over. So a flock supports MCPs. For example, GitHub MCP is a set of tools interacting with GitHub. I'm using Docker as MCP host. I hope you all know that Docker can do this since 2 or 3 months. And all I do is basically give the agent this MCP server. I don't even have a prompt explaining to the agent, please use this to generate some GitHub stories or something. It's just the same stuff like you saw earlier. It gets a project idea in, and then it should basically do a cool project. Let's execute. This can take a little. GitHub MCP server is running. I didn't show what it should even do. It should create an AI-first email client. And if everything goes well, it should create a GitHub repository. It should create issues for it. And it should boilerplate or scaffold some code for it. Right. So when working with tools, Flock also, When working with tools, Flock switches into reasoning mode, which you can see here in the huge table. It's basically, he gets his input, and then you can read what Flock was thinking to get to the result. For example, thought 0, to move forward, I need to generate a unique and appealing project, blah, blah, blah. And at the end, it generated a repo URL. And as you can see, I now have my repository. I have some issues, just 2 this time, but I would argue if you do this with LangChain, you have 300 lines of code prompts, and it still won't work. And all of this without needing to write complex system prompts. That's basically all it got. And based on the names of the variables alone, it thought of using the GitHub MCP server to actually create those issues and these files at GitHub. So my time is over. Sorry for not having a Q&A, but the Q&A is basically the booth presentation. So if you have questions and want to see more demos, please join us in 45 minutes. Good.